Hi guys, we're going to do a recap of all the types of factoring in one little video, just to kind of explain how we know which kind of factoring to use, in addition to how to factor out the problems. So since this one says factor the common factor out, we obviously know what to do. But even if it didn't tell us, you can tell that this is factoring the common factor because of all the different letters and different powers within the problem. So the first thing we do is we divide them all by the GCF, which is 6. And then also we have an x that goes into all of them, and z also goes into all of them, and the smallest power is z2. So we place our GCF out in front of parentheses and put the answer to each division problem within the parenthesis. That all cancels except for -8. Over here the x's cancel and we're left with z to the third, and the y is also left there. And we have 9, lastly. The x cancels, 1 z is left, and the y2 remains. So this is factoring the common factor out. Next we're going to review basic. Here we know this is basic because, first of all, there's no greatest common factor to take out. And even if there was a greatest common factor, it could still be basic. The reason this one's basic is because nothing's in front, and we can't, even if there was, we could divide everything by 1. So what we know is it's the opposite of FOILing. So we know that there has to be 2 parentheses and we have to get m squared when we multiply. So they both have to have m. And we look for factors of 16 that are going to add or subtract to 6, which are 8 and 2. And we know that they have to subtract to 6. That's the only way you're going to get 6. And they also have to multiply to -16. So one has to be plus, one has to be minus. And 8 minus 2 is 6. So now we have factored this one. We're going to go on to another basic factoring. And the reason we're doing this is because it's a little bit different. You can tell here that this has a number in front of n squared. But what's great about this 5 is that they all divide by 5. So it's actually going to be a basic factoring, even though it doesn't look like it in the beginning. So we'll come back to the 5 at the end, but we're going to divide everything. So we get n squared minus 1n, or just minus n, minus 20. So here we're looking for factors that multiply to 20, and they're going to have to add to -1. So if it's a -1, they're probably subtracting. So what we go ahead and do is we take an n in each, so we get n squared, and the factors of 20 that will subtract to 1 are 5 and 4. And in order to get a -1, it has to be a +4 and a -5. Now the thing we can't forget is the greatest common factor we took out in the beginning. So that makes this basic factoring, because even though it looks kind of crazy, there's a number in front that goes into everything. So something that looks a little different can actually still be basic. The next problem we're going to do is an advanced factoring. The reason this one is advanced is because the 3 is a number that's bigger than 1, and 3 does not go into 34 and 80. So instead of dividing everything by 3, which we can't do, we have to look for factors of 3 times 80. So it's kind of big, but we know it's 240, so we might want to make a little list over here. And eventually we'll get it, but you kind of just have to go slow at first. But when you look at it, 24 and 10, after you make your list, this is going to work out well, and whenever in doubt, if it ends in 0 and it's a big number, try 10. So 24 and 10 are going to be our factors, and a lot of people actually put this in a big X, and we referenced that earlier. So factors of 240 from 3 times 80 that add to 34, so +24 and 10. So you could do either way, big X or not. And now we go ahead and we rewrite it. We keep the outers the same. And we have the inner is replaced with 24m and 10m. We split this, and we go ahead and take out the GCF of each. So here it's 3m and 3m and 10 and 10. So we take out that GCF and put our answer in parentheses. And they should end up matching. So as you go through, your parentheses will always match. So you take the 2 things that you factored out, and you put them together in their own parenthesis. And you write the m plus 8 afterwards. Since we never took a GCF out in the beginning, This would be our final answer, and we'd stop here. The next problem we do is also going to be an advanced factoring. The reason that this is an advanced factoring is because, once again, the number in front of k squared is rather large. But when you look through, you do always want to check for GCF. You want to see, can I make this basic, or can I make the numbers a little bit smaller for myself? So since they all divide by 5, let's do that to make it a little bit smaller. And we end up with 5 on the outside, but we can come back to him later, so we actually don't have to write him down. We end up getting k squared, or 3k squared, minus 2k minus 40. Now, the reason we know this isn't basic is even after we take the GCF out, we have this 3 in front. So we know that we actually need to take 3 times negative 40 and put that on the top of our big X. So they have to multiply to 120, and they have to add to negative 2. So we can go through our big long list of factors for 120 again, and as soon as we get it, we can go ahead and stop. So 12 and 10 will subtract to 2, so I'm going to try that out. I know they have to be opposites to get negative 2, so I know if it's a negative 2, the bigger number has to be negative. So now what I do is I go ahead and I rewrite my expression. So instead of writing 2k in the middle, I'm going to write like negative 12k and positive 10k to replace that, and I'm going to keep the end term. Since we have our factors, I'm going to use this space over here. So what we're doing is we're going to split this down the middle, and we're going to factor out our greatest common factor. So we can divide on both by 3k over here and 10 over here. So we have 3k, and we're left with k minus 4. And over here we take out the 10, and we're left with k minus 4. And these should match. So we have 3k plus 10 and k minus 4. And then don't forget, we have that greatest common factor we took out in the beginning, so you have to put them out in front. So now we've done this advanced factoring, a little bit more complicated, but as soon as we took the greatest common factor out, we could see that it was still advanced factoring. Next, we have difference of squares, and the reason this is difference of squares is, notice it's 2 terms. So the last 4 problems have all been 3 terms, which are really easy to do basic or advanced factoring with. And here we always still look for that common factor first. There's nothing that goes into 9 and 25. So we notice they're both perfect squares. So we can go right to our 2 parentheses and put a 3n in each, because we know that will get us our 9n squared, and a 5 to get us our 25, and our opposite signs. And that's really all you have to do, is make sure that it is a difference of squares. So one's there's subtraction, and one's got a square root and the other's got a square root. Just take the square root of each and put them in the parentheses, one with a plus, one with a minus. The last kind of factoring we talked about was factoring by grouping. We know this is grouping because the first thing you look for is common factor. First of all, there's no common factor. Then when you look through, it's got 4 terms. So the only other one that had 4 terms was common factor. And since there's no common factor here, that's one reason, that's factor by grouping. And the other is that there's all these B's. So since they're all the same letter, we're going to try factor by grouping. And even then, sometimes it doesn't work, but we're going to go ahead and try to split this expression. And we're going to take out the b squared for sure, because that's the power that goes into both of them. And I think 3 is the biggest number that goes in here. And we'll be able to tell if it's not. So you have 3b squared came out, and then we're left with a b and a minus 5 when we divide. And over here, we're going to divide by 5. So we're going to have positive 5, and our answer would come out 8b minus 5. So here we know we made a mistake, and I can see where that's at. That's over here. This should have been an 8b minus 5. And when they don't match up, you always want to go back and check, did I make a mistake or did I pick the wrong factors? Because this 8 and this 5 don't have anything else that goes into them, that's how we know we did pick the greatest common factor. At the end, we take our 2 outsiders and put them together in a bracket. And our repeater we write once. So we're writing something in double distribution. And then we have our final answer. Great job reviewing all 5 methods of factoring in 10 minutes. That's an awesome job. Hopefully you do great on your quiz.